the what's going on, and that is what's happening, right? It's also the constant difference. So the book calls it the constant difference. I've called it the what's going on. We've also had the constant ratio, but let's leave that out for a minute. What it really is the slope. It's the rate of change. It's the slope. And slope is change in y Does anybody know what the class is next door? It's making all that noise, the teacher? No, it's calculus. Yeah. So you want math to be fun, get to calculus. It'll be hard, but it's fun. Okay. Especially when you have a teacher like Mr. Bartlett. He's pretty cool. Okay, change in y over change in x. The formula for that is this. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, we've been doing that for a while. You just didn't know it. The other way that some of you may have seen this written, perhaps, is something triangle y over triangle x. This is called delta y over delta x. And the triangle just means change. It's saying exactly the same thing as this. This is your triangle. Okay, change in y over change in x. Delta y over delta x. We don't have that symbol in our alphabet. I wish I was Greek. I think a symbol of a triangle would be kind of cool. All right? Now, what's the starting point? Where do we start? Well, that's where y equals 0. I'm sorry, x equals 0. This is your y-intercept. So if we put all this together, it looks like this. Y, or f of x, equals the slope. Does anybody know what letter we use for slope? I wish it was S. It would make more sense. It's actually M. Times x, let's put an M here, plus or minus b. Start this y-intercept, that's b. So we have M and we have b, and we have an x and a y. So how we've seen this is something like this. Right? And I and the curriculum, the book, has been asking you for a while to figure out what's going on here. So what's going on? Plus 2, right? When we change by how much? Plus 1. So that what's going on is 2, or plus 2, technically over 1, but we don't really need to write the 1. In this case, we don't. And that's the slope. So I've got most of my equation solved. Y equals 2, don't forget the x. The slope always multiplies the x. How many times are we going to do this adding of 2? How many times is that? As many as we want, right? X, right? We're going to add 2 as many times as we want. Now, where do we start? Well, I can do one of two things. I I can either work this backwards and find 0, which would be fairly easy, or I can plug in a 1 and try to make it equal 3. Right? Just like we've done. 2 times 1, when x is 1, we know the answer has to be 3. But what change has to occur to make that true? Plus 1. There is your linear equation. We've been writing linear equations. The explicit is really a linear equation for a while now. What if we have a graph and let's say my graph has a point that comes through, or a line that comes through and does like this. Oops, I did a pretty bad job there. My card moved. That's all right. I'll make it work there. And we want to write the equation of this line. It's simple. All we have to do is pick 2 points that we can identify very clearly. This one and sort of that one. Okay. Sorry, my drawings. My card slipped. What's the rate of change? Well, the rate of change is how do you get from this guy to this guy without going diagonal? I've got to go up and over. Slope is always rise over run. In that order, no exceptions. So I've got to go up 2 and over 3. So my rise over run, in this case, is 2 over 3. And it's a fraction. That's okay. We want slope to be a fraction. It's either going to be a fraction or a whole number. So I'm ready to write the equation. Are you ready? Y equals 2/3 x. How many times am I going to go up 2 and over 3? As many times as we want, right? X times. Okay, where does it start? Right, -2, the y-intercept. There's your starting point. That is your adjustment. It's your y-intercept. There we go. Now you can find any point on that line. Slope, y-intercept. Okay. Let's talk about positive slopes and negative slopes real quick, because you can tell just by looking at them. If I draw a graph and I put a line in like this, is the slope positive or negative? Why? Positive, I agree. Going up to the right, exactly. So this is a positive slope, because it's going up to the right. How we read slope is this. We read it just like we read pages on a book, from left to right. So what I like to think about is, for a positive slope, since I like to ride bikes, to me, this is the guy or girl riding the bike, and they're really struggling to go uphill. It's uphill, okay? The bike is always going from left to right. So that's a positive slope. This one, negative, right, it's down to the right. So this bike rider, life is good. It's an irresponsible bike rider, I know, because they're riding without a helmet, but I have this firm belief that there's some value in the feeling of wind through your hair, but don't tell your parents that I said that. Okay. So this bike rider's going downhill. This slope's going downhill. That's a negative slope. How about this? What's that? Neutral? That's a good word for it. It's horizontal. It's constant. I like all those words. What's it like? The floor. Yeah, it's like the floor, right? It is. It's a Y. So how much slope is there to the floor? Zero slope. Exactly. This is a zero slope. Some bike riders like zero slope. I kind of get bored with it, actually. It's just, yeah, it just gets kind of old. I like hills. I'm willing to go up the hill to be able to go down the hill. And what about this? What happens if you try to ride down this hill? Right? This one's a problem. Okay? This slope is a problem. You can ride down a vertical for a very short distance if the physics are just right for you, but to ride down a long wall or a long cliff, it's not going to go well for you. This is an undefined slope. Undefined. Okay. And what makes each of these special is, as a fraction, the positive slope is going to be a positive number over a positive number, or a negative number over a negative number. A negative divided by a negative is a positive. For the negative slope, you're going to have a positive over a negative, or a negative over a positive. Maybe I should do it like this. There we go. That's better. That makes more sense with the negative. Or it can be written this way. A negative slope. Some numbers in there. Yeah. So the negative can go on the top number, the bottom number, or in the middle. It doesn't matter. And then if it's in the middle, you get to pick. Actually, it doesn't really matter where you put the negative on a negative slope. Zero slope is going to have a fraction of 0 over some number. It could be positive or negative, but if you have 0 and a number down here that's either positive or negative, well, it's still 0, right? What makes this undefined is this. As a fraction, this is some number, either positive or negative, divided by 0. And in mathematics, dividing by 0 is a big no-no. You know why, don't you? The dinosaurs brought their own destruction. I know it's true because it's shown in this shirt up here. So the T-Rex, he's like getting pretty smart. And he's got a chalkboard over here. Somebody made a chalkboard for him. And he's got 5 divided by 0. He's dividing by 0. But what did he do? He brought Armageddon onto himself. The big asteroid came in, crashed down, killing him. Not because of some fateful event. It was because the universe had to fix it. You can't divide by 0. And so, guess what? If you divide by 0, you also may bring Armageddon onto the human race. So don't divide by 0 ever. Okay? Because it's not 0. It doesn't exist. It doesn't make sense. some number of parts, but it takes 0 parts to make a whole? Does that make sense at all? I don't think so. It takes 0 parts to make a whole, but I've got some parts. That doesn't make sense at all. Undefined. Undefined. So when we end up with something like this, it's a vertical line. All right, let's get you guys going on the task.